Welcome to the Quantanix YouTube channel. This is Time Travel Podcast, Episode 5.
Great to be here.
Today, we're diving into something really out there. Parallel timelines and multiverse theory.
Yeah, this is definitely mind-bending stuff.
We've looked at some, fascinating work in quantum mechanics, cosmology, and our goal today is to unpack this pretty radical idea that, well, our reality might not be the only one, and see how these concepts really challenge our basic understanding of cause and effect.
Absolutely. And it's not just dry theory, is it? The implications. They touch on everything.
Exactly, like free will, time travel itself, even what we think of as real. You might be surprised where this goes.
It definitely makes you step back and reconsider some, fundamental assumptions about the universe.
Yeah.
And our place in it.
Okay, so let's dive in. Where do we start? I guess the idea of multiple realities often traces back to quantum mechanics.
That's usually the starting point, yeah.
Yeah.
Specifically, the many worlds interpretation, or MWI.
Right, Hugh Everett III back in
Yeah.
57.
That's the one, 1957. And the core idea is, it really flips our usual thinking on its head.
How so? What's the main concept?
Okay, so normally we think when you measure something quantum, the universe kind of picks an outcome, right?
Yeah.
Like Schrodinger's cat is either alive or dead when you look.
Yeah.
MWI says, no. Instead of picking, the universe splits. Every single possible outcome of that measurement happens, but each one happens in its own separate parallel universe.
So for the cat, there's a split, and you get one universe where the cat's alive and another totally separate one where it's dead.
Exactly. Both are equally real. The act of measurement or observation is what causes this branching.
Wow. Okay. So it's not that one possibility wins out and the others just display.
Vanishing, they all play out just elsewhere
Yeah.
in these other branches.
And how does that change the whole cause and effect picture? That seems like a huge shift.
It is, because if every possibility sparks a new branch, that nice linear chain of A causes B, does B causes C, it becomes more like a tree, a constantly branching tree. So an event here might lead to outcome X, but in another branch, the exact same starting event could lead to outcome Y. Causality isn't this single universal chain anymore. It's localized. It operates within each branch.
Okay.
And a really important point here, it gets rid of something called wave function collapse,
Right.
which is actually a bit of a headache in other quantum interpretations. MWI says there's no collapse. Everything just coexists across the branches.
Which then messes with things like the Novikov self-consistency principle, doesn't it? The idea that timelines have to be stable to avoid paradoxes.
Precisely. Novikov relies on a single consistent timeline. But if timelines can branch, well, you can have contradictory outcomes. They just exist in different branches, so the paradox dissolves.
Okay, quantum branching realities. That's already a lot to take in. But then we zoom out to the whole cosmos and run into eternal inflation and bubble universes. This sounds even more like sci-fi.
It does. It really does.
Okay.
But it actually comes from serious thinking about the Big Bang, particularly the work of people like Alan Guth and Andre Lin. The idea is, that incredibly rapid expansion phase right after the Big Bang. Inflation.
Yeah.
Eternal inflation suggests maybe it didn't stop. Everywhere, like quantum fluctuations in the early universe's energy field, the sort of cosmic fuel driving the expansion, might have caused some regions to just keep inflating indefinitely.
Keep inflating.
Yeah, and as they expand, they sort of pinch off, forming these vast, separate, bubble universes.
Bubbles, and are these just like slightly different copies of our universe or something more radical?
Potentially much more radical. That's a key part. Because they form kind of independently, they can end up with totally different fundamental constants, different strengths of gravity, different particle masses, maybe even different laws of physics altogether.
Wow.
And here's the kicker: causal disconnection. Meaning something happening in our bubble, say, a huge supernova, has absolutely zero effect on what's happening in another bubble. They're separated by this vast, continually expanding space. They're causally isolated, like separate soap bubbles floating apart.
So each bubble is its own self-contained causal system.
Essentially, yes.
Okay, let's try and connect these two big ideas then. We've got the quantum branching timelines and these cosmically isolated bubble universes. How do these let us, theoretically at least, sort of escape traditional cause and effect?
All right, let's take the quantum branching first. Think about that classic time traveler scenario someone goes back to, say, prevent World War I.
Right, the standard paradox setup.
In a single timeline, that's a mess. You change the past, maybe prevent your own existence, paradox. But with many worlds, the traveler's actions don't erase the original timeline.
Ah, they create a new branch.
Exactly. They split off a new reality where, okay, maybe the war is averted, but the original timeline, the one they came from, it just keeps going, war and all.
So the cause wanting to stop the war and the effects stopping it in that original timeline get disconnected.
Precisely. Causality still works fine within each branch, but there's no single universal cause and effect chain linking them in that simple way anymore. The paradox vanishes because the conflicting events are in separate realities.
That does neatly sidestep the grandfather paradox, too. You don't erase yourself. You just create a branch where you weren't born, but you still exist in the branch you started from. And with the bubble universes, the escape seems even more fundamental.
Oh,
Just sheer distance, cosmic horizons.
totally. The expansion that creates them also ensures they're causally cut off.
Yeah.
Light, information, anything. You just can't cross the gap. It's expanding too fast.
So you could have universes where history is unrecognizably different.
Absolutely. Imagine a universe where dark energy took over way earlier, maybe galaxies never even formed, or one where, I don't know, the strong nuclear force was weaker, so stars couldn't ignite.
Right.
These places would operate under completely independent causal rules with entirely different histories.
This has to lead to some deep philosophical territory, especially around free will versus determinism.
Oh, definitely. In a standard, single, deterministic universe, you could argue that every choice we make is just the inevitable outcome of prior causes. No real freedom.
Yeah, that's the classic deterministic view.
But the multiverse, it offers a potential way out, or at least a different perspective. What if every possible choice you could make actually does happen, just in a different branch?
So making a choice isn't about causing one outcome instead of others.
Maybe it's more about which branch your consciousness kind of follows. If all possibilities are already laid out across the multiverse, perhaps free will is the experience of navigating one path through that vast possibility space.
So not creating an outcome, but selecting from pre-existing ones?
Yeah.
That sounds a bit like, isn't there a philosophical idea called modal realism?
Exactly. You're thinking of David Lewis.
Yeah.
His modal realism basically says all possible worlds are just as real as ours. Combine that with the physics of the multiverse.
And suddenly every potential future branching off from every decision point might actually exist somewhere.
Right. Our life becomes a sort of journey through this landscape of actualized possibilities.
Lewis also had this interesting take on why we call our world actual, didn't he? It wasn't about it being more real.
Correct. He argued actual is an indexical term, like here or now. It just points to the world we happen to be in. Someone in another universe would rightly call their universe actual.
Okay.
And this makes causality itself relative. What's a law, what's possible, what causes, what it might depend entirely on which universe you're indexing from. Reality and its causal rules become localized.
These are obviously enormous concepts, and not everyone in science is sold on them, right? What are the main criticisms or challenges?
Yeah, there's definitely debate. The biggest hurdle is probably empirical verification. Testability.
Because they're causally disconnected, how do you test something you can't interact with?
That's the problem. If these other branches or bubbles are fundamentally cut off, how do we observe them? It's a major scientific objection. Now, some people are looking for indirect signs. Maybe subtle temperature variations, anomalies in the cosmic microwave background radiation, the echo of the Big Bang. Some models suggest if our bubble collided with another one very early on, it might have left a faint imprint. But it's highly speculative. Very hard to confirm.
Right. Looking for a cosmic bruise, basically.
Sort of, yeah. And then there's the philosophical objection, Occam's razor.
Don't multiply entities unnecessarily. Why invent infinite universes if one explains what we see?
Exactly. Thinkers like Roger Penrose raise this point. Why this ontological proliferation, this huge increase in the number of things we're saying, exist if we don't strictly need it?
What's the counter-argument to that?
Proponents would say models like eternal inflation aren't just pulled out of thin air. They might actually arise naturally from our best current theories of quantum fields in the early universe.
Ah, so the multiverse isn't an extra assumption, but maybe a consequence of assumptions we already make.
That's the argument. That the physics might lead us there, whether we find it philosophically tidy or not. It's an ongoing discussion for sure.
Fascinating. But even if the jury's out scientifically, the idea of the multiverse has undeniably had a huge impact, hasn't it? Culturally, even scientifically.
Oh, absolutely. Just look at science fiction, especially time travel stories.
Right. It changed everything.
Instead of writers tying themselves in knots over paradoxes, they can just say, okay, changing the past creates a new timeline. Branching realities become the solution.
Like the TVA in the Loki series, right? Their whole job is managing those branches.
Exactly. That's a perfect pop culture example. Pruning variant timelines. It's a very different model from older sci-fi that stuck closer to that Novikov single timeline idea.
It definitely frees up storytelling, but are there any maybe less fictional links? Like on quantum computing? That seems like a leap.
It's theoretical, but yes. David Deutsch, who's a pioneer in quantum computing, has explored some really mind-bending ideas involving things called closed time-like curves, CTCs, basically time loops. And one speculative idea is that maybe quantum computers could somehow harness these parallel realities. Like if you could entangle qubits, quantum bits, across different branches.
You could use the multiverse for computation.
Potentially. The idea is you might be able to perform calculations in parallel across these realities, solving problems that are just impossible for classical computers or even standard quantum computers operating in just one universe. It's way out there, very speculative.
But it shows the concept isn't just philosophical or fictional. It's sparking theoretical physics ideas, too.
Precisely. It pushes the boundaries of what you think might be possible.
Okay, so as we start to wrap this up, what's the core takeaway here? When we think about parallel timelines, the multiverse, and how they relate to causality.
I think the main shift is seeing causality not as this absolute universal law, but potentially as something local, something that operates consistently within a given timeline or within a bubble universe.
But not necessarily between them.
Right. The existence of countless other realities, possibly with different rules, different histories. It kind of dissolves the idea of one single overarching causal structure for everything. Cause and effect becomes context dependent.
It feels a bit like, you know how Einstein showed space and time aren't absolute, but relative to the observer?
That's a really good analogy, actually.
Is this sort of doing the same for causality, making it relative to the specific reality you find yourself in?
I think that captures it well. Just like relativity gave us observer-dependent space-time instead of a fixed background. Multiverse theories suggest causality might not be this rigid universal chain, but more like a vast branching network. Each path has its own rules.
It definitely forces you to rethink things. Just contemplating the possibility. Countless realities existing alongside ours. It really changes your perspective on, well, everything. Your choices. The universe's potential.
It's profound, isn't it? It opens up such vast possibilities.
Well, thank you for joining us for this deep dive into parallel timelines and multiverse theory. It's certainly left me with a lot to think about.
My pleasure. Always fascinating to extract these ideas.
Thank you for joining us. Like, subscribe, and tune in next time for more adventures on the Time Travel Podcast at the Quantanix YouTube channel.